So this is the first demonstration in chapter 7 of the Ars Magna. The text of the article goes through this demonstration in more detail, but as with many geometric demonstrations, it's useful to see the sequence of steps involved in the construction rather than just seeing it just as a text. So here's the problem in hand. Cardano starts with three positive numbers, x, a, and n, that are given with this relationship holding. What we want to do is to construct two positive numbers, y and b, so that these three equations hold. So Cardano looks at this as a relationship between volumes. And in the following, this is our picture. This is x, these red bars. And so this volume here is x cubed. I'm calling this length, orange length, alpha. So this box with x squared at one end and length alpha, that's going to be our number n. And then a is this entire length here. And that is going to be, well, ax squared is the entire volume. So this picture in red and orange, that's my x's. This is the y cubed plus n equals by. That's going to be the purple and blue. Here we'll have y is these blue bars. And so this chunk here, if this is a vertical, that's my y cubed. And then we want this chunk at the end, this volume here, to be the volume n as well. B is the base of this yellow area or green area. And y is the height. So this entire volume here is b times y, but it's broken up into two parts, y cubed and n. This little purple line here will later be called beta. So that's the notation that we'll be using. Given the little red and orange picture, can we build the blue and purple picture so that we get y cubed plus n equals by and these various relationships between x and y? So Cardano actually draws these things in a plane. So this is our x's and alphas. There's an assumed height here of x. So this volume here has a base plan, which is a square of x and this long rectangle. And that's what Cardano actually has in his pictures. Again, this is a, and x cubed plus n equals ax squared. And x plus alpha equals a as well. And for concreteness in GeoGebra, I took x equals 2, a equals 18, and n equals 64. So how does he start his construction? Well, the first thing he does is he takes the line alpha and he takes that out and moves it down here. And he takes the line segment x and we'll move it over here. So he picks out alpha and x as his key points to start his construction. And he creates a sequence of four proportional quantities between alpha and x. And so he calls this one E, and then we have another one, I'll call that one Y. That is what our Y is going to be. So four proportional quantities, of course, that kind of a problem, constructing four proportional quantities between two given problems, is one that's known to antiquity. It can't be solved with Euclidean tools, but that would have to wait till the 19th century to be proven, I think. So he assumes that you can do that. He constructs them. And then he says, okay, well, I'm going to build y squared. So here's y squared down there. And then he builds the coefficient b. So he takes b and he defines b to be a times e. And remember that a is this entire length. And e is this one of his four proportionals. So e is this length, and this entire length side is a. So he's got an area, A times E, and he says, okay, I'm going to take my y squared, that's this area, and I'm just going to expand it a little bit up so that I get a rectangle whose area is the same as B. So now he expands his rectangle y squared up by an amount beta. That's beta. So that this square, this rectangle and this rectangle, the two yellow rectangles have the same area. So the area here for both of these is B, which is equal to A times E. So that's what our green area is. Great, so now we've got beta. So in fact, at this point, we have the diagram that Cardano has in the Ars Magna. It just has this equation, a little bar for E, and then y cubed plus, well, m equals by, because we don't know yet that y, that they have the same constant. That's one of the goals. So this is the picture that he has in his book. So if we look back at the volumes, this is again where we are. We've got our area B set up here. So by is this volume in blue and purple. M is this volume, which we hope is equal to n. And from this, you can tell that this is actually beta times y squared, right? The purple bar is beta, and then the face of this is y squared. This is my equation x cubed plus n equals ax squared. This again is the coefficient a is this length. And n is x squared times alpha, and alpha is what I'm calling this orange bar. So we want to show that n is equal to m, and these two other relationships between x times y and b. So Cardano's method for doing this is, well, he's going to show that beta is actually the fifth proportional quantity, that beta can be put in as a fifth quantity in proportion with the rest of the other numbers. So how does he go about doing that? Well, first we need to talk a little bit about proportions and how you can multiply proportional quantities together without changing the product. So here are seven proportions in 7 quantities in geometric proportion. This is A, little b, little c, alpha, beta, gamma. For us, proportions are geometric series. If we take this to be A, then this is A times R squared, A times R cubed, A times R to the minus 1, etc., where I've taken R equal to 1.5 and A equal to 5. So we think of the geometric series, Cardano doesn't, but he knows how to multiply things so as to keep the products the same, even though we've changed the proportions. So imagine taking the product B times gamma. So this is B, and this is gamma. B times gamma, we look at this and we say, well, that's AR squared times AR to the minus 3. That's A squared times R to the minus 1. But that's the same thing you get when you multiply A times beta. Because imagine we go down 1 from B. So we're decreasing the power in R by 1, but we go up from gamma by 1. So changing the power again by 1, right? So we haven't changed the power of the product at all, right? A times R to the minus 2 times A times R, right? Which is A beta. That's going to be the same thing as B gamma. A times alpha, well, if we take B and we go down 2 steps, to balance going down 2, we should go up 2. So if we go down 2 and up 2, down 2 from B and up 2 from gamma, right, we should be able to preserve the product. So Cardano knows that, and he uses that quite often. He doesn't quite think of proportions as a geometric series. So how do we go about showing beta is a fifth proportional quantity? We have this picture. We know that B equals A times E. That's the two yellow areas. They're the same area. What we also know is that alpha E equals y squared. Geometrically, in the picture, y squared is this area. Alpha is this part of A, and E is this. So this area is alpha E. These two green areas are the same. Why are they the same? Well, if I take alpha times E, if I go down 1 from alpha and up 1 from E, I preserve the product. So alpha times E is equal to y squared. So these two areas are the same. So what does that tell us? That tells us that we know that the area of this whole rectangle and the area of this whole rectangle are the same. They're both B, or A times E. We know that the dark green areas are the same. So that tells us that the yellow areas are the same. But the yellow area here is beta times Y. The yellow area here is X times E. So beta times Y equals X times E. Or we can rewrite that as X over beta equals Y over E. So the ratio between X and beta is the same as the ratio between Y and E. So that means beta is in fact the fifth proportional quantity with the other ones. So why is that important? Well, we want to be able to show that this is equal to this. But let's keep in mind that M is beta Y squared. That's this volume. And N is alpha X squared. That's this volume. So, and then we can get to the other ones once we're through with that. So N is alpha X squared, beta is M is beta Y squared, alpha X squared, beta Y squared. These are both products of proportions. So what does that mean? Well, if we take alpha and go down 4, that takes alpha to beta. We take X and we go up 2 twice, once for each of the two X's, we get Y squared. So alpha X squared is equal to beta Y squared. So the constants N and M are the same. So finding E in terms of N, well, we know alpha X squared equals N, but alpha X squared is equal to E cubed. How do we check that? Well, down 2 from alpha, down 2, up 1 twice from X. So alpha X squared is the same thing as E cubed. So it gives me N equals to E cubed, or finally E equals cube root of N. And the equations we're dealing with, what that allows us to do is find out what B is, right? B was A times E, but we know that E is cube root of N, so it's A times cube root of N. And XY, well, same thing we've been doing before. X times Y, if we go down 1 from Y, if we go up 1 from X, we get E squared. So XY equals E squared, but E is equal to the cube root of N, so it's the cube root of N squared. And now we have everything we need to establish our result.